Today, we are diving deep into a topic you've probably heard a million times but might still find a little confusing: blockchain. You hear it mentioned with Bitcoin, NFTs, and all sorts of futuristic tech, but what is it really? Stick around, because by the end of this video, you'll understand blockchain like a pro. So let's start with a simple analogy. Imagine a digital notebook, but this isn't just any notebook. It's a special notebook that's shared among a huge network of computers. Every time someone adds a new entry, or a transaction, it's not just saved on one computer. It's copied and sent to every single computer in the network. Each new entry is called a block. Now here's the cool part. Each new block is cryptographically linked to the one before it, creating a chain. Think of it like adding pages to a notebook. But each new page is permanently glued to the previous one with a super strong, unbreakable digital glue. This glue is created using complex math called cryptography. This chain structure is what makes a blockchain so incredibly secure. Why is this so secure? Well, imagine someone wants to cheat and change an entry in the notebook. Maybe they want to alter a transaction from a few days ago. To do this, they wouldn't just have to change the entry on their own copy of the notebook. They'd have to change it on more than half of all the computers in the entire network, all at the same time. And because each block is linked to the one before it, changing one block would mean they'd have to change every single block that came after it. This is practically impossible, making the data on a blockchain tamper-proof and permanent. This is what we call decentralization. There's no single person, company, or government in charge. No central authority owns the notebook. Instead, the power is distributed among all the participants in the network. This eliminates the need for a middleman, like a bank or a government agency, to verify and process transactions. It creates a system that's transparent, because everyone can see the entries, but also secure because no single entity can control or manipulate it. Let's go back to Bitcoin, the most famous example of blockchain technology. When someone sends Bitcoin to another person, that transaction is recorded as a block on the Bitcoin blockchain. The network of computers, often called miners, works to verify that the transaction is legitimate. Once verified, the block is added to the chain, and the transfer of value is complete and irreversible. This all happens without needing a traditional bank to facilitate the process. But blockchain is so much more than just cryptocurrency. Its potential is massive and touches almost every industry you can think of. Take supply chain management, for instance. Companies can use a blockchain to track a product from the factory all the way to the store shelf. Every step of the journey, from sourcing raw materials to shipping and delivery, can be recorded as a block. This creates a transparent and unchangeable record, so you as a consumer could scan a QR code on a bag of coffee and see exactly where the beans were grown when they were harvested and how they got to your local shop. This helps fight counterfeit goods and ensures product quality. How about voting systems? A blockchain-based voting system could create a secure and transparent record of every vote cast. This would make it incredibly difficult to tamper with election results and could increase trust in the democratic process. Each vote would be an anonymous but verifiable transaction on the blockchain. In healthcare, blockchains could be used to securely store and manage patient medical records. You would have complete control over your own health data, granting temporary access to doctors or hospitals when needed. This would give patients more power over their private information and ensure that their records are accurate and can't be altered without their permission. Then there are smart contracts. These are a game changer. A smart contract is basically a self-executing contract with the terms of the agreement written directly into code. They run on the blockchain and automatically carry out the terms when certain conditions are met. For example, you could have a smart contract for a rental agreement. The contract could automatically release the security deposit back to the renter once the digital key is returned on the move-out date, without any landlord or third party needing to get involved. It automates trust. Of course, the technology is still evolving, and it's not without its challenges. Things like scalability, how many transactions can be processed at once, and energy consumption, particularly for blockchains like Bitcoin, are big hurdles that developers are actively working to solve. Newer blockchain models are being developed that are much more energy efficient and can handle a much higher volume of transactions. So to recap, what have we learned? A blockchain is a decentralized, distributed, and immutable digital ledger. Decentralized means no one is in charge. Distributed means the ledger is copied and spread across many computers. And immutable means once something is recorded, it can't be changed. These core features are what give blockchain its power to create systems that are transparent, secure, and don't require a traditional middleman. From finance and cryptocurrency to supply chains, healthcare, and voting, the applications are truly mind-boggling. We are just scratching the surface of what's possible. It's a fundamental shift in how we think about data, trust, and transactions on the internet. Understanding blockchain is like learning about the internet in the early 1990s. It might seem complex at first, but its core concepts are revolutionary and will likely shape our future in profound ways. Hopefully, this explanation has cleared things up and given you a solid foundation. Now, when you hear the word blockchain, you'll know exactly what people are talking about. Got any questions? Drop them in the comments below, and I'll do my best to answer them. See you in the next video.